Hello, and this time we're looking at an old A-level question from a C2 paper, and it's about trigonometry, but it's in radians. And so if you haven't done radians before, it might look a bit freaky to have all these pi's in, but essentially if a circle goes round and is 360 degrees, then there's another way of measuring that angle around a circle, just like you can measure distance in miles or kilometers. You can measure this in radians, and we define a full turn all the way around as 2 pi radians, which is a little floating c. Instead of a floating O, it's a floating c. And so when it says sketch this for 0 to 2 pi, it's essentially saying for 0 to 360, okay? And otherwise you just do the exact same thing. So sine, cos, it all works the exact same way. It's like, you know, the method for working out a speed in miles per hour is the same for meters per second. You just use different units. So otherwise it's just the same. So if we think about what this should look like, it should, in fact, let's get rid of this. It should look like this. For sine, it should look up and down, and obviously it would be symmetrical. I've done a terrible job there. It's all wibbly, but you get the point. Yeah, it should look like that. But when we look at the question, it's not sine of x, it's sine of x plus an amount. And then we need to know roughly what that amount is, and as we're not very good at radians so far, let's convert it into degrees. So 2 pi is a full circle, which means pi is there, so we're 1/6 of the way round half a circle. Okay, if half a circle is 180 degrees, we're 1/6 of 180, which is essentially 30 degrees. So it's x plus 30. Now, if you remember from your transformations of graphs, when you add something to the function, if you add something to the x, if you add something to the function f of x plus 3, just shifts the whole thing up by 3. But f of x plus 3 shifts everything to the left by 3. And we've got f of x plus 30, so it's going to shift everything to the left. Now I'm going to draw this really badly, I'm sure. Okay, so if this shifts to the left, it's going to, by 30, it's going to start somewhere like that. Dotted line, because that's out of our range. And then here it's going to come up to the top, down, and then it's going to carry on until it gets to the limit where it was. So we've still got one sort of amount. Yes, it starts and finishes at the same point. It's one sort of part of the wave, but we're not starting at the nice, you know, at that bottom point where it touches anymore. We're going from here through to there. So that's what the sketch is looking like. And then we would obviously need to sort of label on some values, I think, for probably get a mark for the shape, and then for marking on some of the points. So if that's 0, that would have been 180, or pi. Whoa. Get rid of that. So if that's 180, it's been shifted by 30, then instead we label this as 150. And if that's 360, then that's 330. So we're on our way to sorting out part B as well, because part B says write down the exact coordinates of the points where the graph meets the coordinate axes. Okay, well, we've got 2 of them. We've got that one at comma 0, obviously, and we've got that one, and then we just need this one here. And you have to stop and think, okay, well, this one here is going to be the same height as normal sine, but at 30, because remember this was shifted 30 there. So whatever the value, the height of that would be for sine 30, that will be the height there for that, where that goes through. So you can just use your calculator if you don't know what that is already. So you can see it's just, you know, normal questions about sine. It's just that we had to turn them from if you can't think fluently in radians, you just have to convert it into radians. Now it says solve between 0 and 360 this equation here, giving your answers in radians to do decimal places. Well, again, this is exactly like things that we do in degrees. we can do the inverse sine of this value and get a value for that bracket. But that's when we have to do what some people call the cast diagram. Some people call all students talk crap. We're doing sine, and it's a positive value. So one value is going to come in this quadrant, and the other value is going to be in the other quadrant, 180 degrees minus the same answer there. And remember to do that cast diagram at the point of inversing the sine. So you've got to work out your other value of x plus pi over 6, and then when you have worked out those two values, that's when you scale them back. Okay, now the fact that we're going from 0 to pi, we don't need to convert the, so normally what you do is you say, okay, well I've added pi over 6 here, so the range I'm working for the whole bracket is going to be pi over 6 is less than or equal to x is less than or equal to 2 pi plus pi over 6, and check that, get all the values out here. But because we're in the first two quadrants, that's not going to really be affected, I suppose, unless the first answer is going to come out at less than pi over 6, then I suppose it would come out high. Yes, you'd have to go all the way around to get the next one, but I don't think that's going to happen. Apologies if my guessing is wrong there, but the fact that that's higher than 0.5, I would suspect means that it's going to come out. It's going to come out within that range without having to worry about it. And give your answers in radians. Well, that's fine, just as long as your calculator's in radians. So let's just check that we can do that as well whilst we're here. So here's my calculator. There's a little D there that shows I'm in degrees. So on this calculator, it's shift setup. Nope, didn't press shift properly. Shift setup, angle unit, and just turn it into radians. Don't worry about gradients, they're rubbish. They basically say that a whole circle's 400 degrees instead of 360, and 90 degrees is, sorry, a right angle is 100 degrees. Absolutely useless. Apologies if there's people out there who think, actually, I use them and they're quite useful. I don't know of a good use for them, and certainly not for your A-level, so forget those. Radians is what we want. And now do the question. Just remember, when you finished, put it back. Always return it into degrees, because otherwise you'll do another question, forget you're in radians, get a load of waffle that makes no sense to you, and you'll get all in a fluster about it. So make sure you always put it back. Okay. I hope that makes sense. If not, you can put something in the comments below and I'll try and fix it, but otherwise, ta-ra for now.